Okay, we'll start. We have seen secure components, operator A, okay, transformation from other segments. We have seen this all, okay, IR, IY, IB, how it could be defined and how it could be uh, converted, okay. A few observations I would like to deal with you or could tell you about these observations, what we observe while studying this. Few observations are written over here. We'll seek into that particular segment. Okay. Now, observation one. Okay, this is observation one. It says if a three-phase system is balanced, okay, only positive sequence components are present. Okay, or say that if a three-phase system is balanced, only the positive sequence components are present. These observations will help you in solving a lot of problems, and you could answer if in many segments. Okay, so example what they have mentioned, in a balanced three-phase system, the current in each phase is 10 ampere. The phase sequence in RLB find the symmetrical component. So these are of balance. So in each phase there is 10 10 10 10 ampere current in each phase, which could be referred in this manner, that is IR would be 10 at 0 reference and YY would be 10 240. That would again would refer as A square I0, and this IB at 10 120 degree would consider as A 10, right? Now we'll see from these particular segments. Okay, now consider, okay, consider this. This is your balanced one. It will be same as the form. Okay, the direction is given in this direction. IR is given, IP is given, IC is given. Now, so if you have to find your sequence component of all these, so you could find using this particular framework that IR0, IR1, IR2 would equals to I1, I1, 1, 1, 1. This matrix, that is A operator matrix. Your I R by B equals to 1 by 3 A operator matrix by R Y B. This would be written wrong. This would be your 0 1 2, means phase sequence matrix would equal to 1 by 3 A matrix, A operator matrix by all three phase current matrix. Okay, so which says, okay, these are the notes will helpful in your gate part. Okay, you could revise and you could do a lot of things while studying these format and all. Okay, so this says that I0, I1, I2 equals to 1 1. Where we have your 10 degree, okay, A10 and A square 10 A10, right? On multiplying this part, IR0 equals to 10 A square plus 10 into A square would be your 10 1 plus A square. That would be your 0, right? Now IR square equals to 1 by 3 10. I will tell you why it is being in this particular segment, if you multiply this, or if we add this particular segment and we take common 10 from that, so we are left with this, that is 1 plus a square, and we know that 1 plus a square is equals to 0, so that's why it will be multiplied with the whole terminology and it will become 0. Okay, now if we multiply for IR1, that is a positive sequence, okay, for the positive sequence, this IR1 would be having this into this, so it will be uh, 1 plus 1, right? A and it's a square 10, so it's a cube 10, and again it's your a square and it's a, then it's again this your a cube 10, so it will be your 10. A cube means 1, as it is denoted 1 into 10, and a cube is 1 into 10, so it will be 30 by 3, that is a 10 MB. That's what we are getting, right? Similarly, if we go for IR2, it's 1 by 3, 10 by a to the power 4, that will be as working as your a plus a square 10. So if we'll take common 10, we'll again got this equation that will be equal to 0. Now, so you could see your 0 sequence and your negative sequence is 0. Only we have left with positive sequence, that is your 10 ampere, this I12. Okay, so this observation is made while seeing, okay, while seeing that if a three-phase system is balanced, only positive sequence components are present. Okay, this is a thing that we observe in this particular segment, right? Now another observation number 2, it says if a three-phase system is balanced, okay, all the three sequence components may present. Okay, so now what it says, that if a three-phase system is unbalanced, okay, if it is unbalanced, then all the three-phase sequence, okay, component may be present. Okay, we'll see how they have solved with one of the numerical given behind just below. Okay, according to that will be soon. Okay, now the example what they have taken, okay, in a balanced three-phase system, the current in each phase is a 10 ampere. Okay, now the phase sequence is in our YV. This is the phase sequence they have given, and each phase consists of your 10 ampere current. Okay, now the another segment what to be for the unbalanced category they have provided now the fuses in Y and V phase are blown off, right? Means they are unconnected, means if this is your connection, okay, if this is the connectivity of the fuse, they have blown off, they have, okay, they have removed, they have opened the fuses, connection of the fuses. Okay, so this particular segment what they have given as a unbalanced part, you will understand in the figure what it is given in the below. Okay, hold a minute, just a minute. I will return back in a few minutes, please. Okay, I went to this diagonal. The condition is very bad at this particular location in Jamshedpur. I don't know why suddenly it's thundering and all. Okay, so see in this figure, where were we? Okay, we were in this particular segment, right? Okay, that was the question, and over here they have drawn, they have drawn this particular segment where IR, IY, and IB is given. Okay, three phase, and these two fuses are blown off. That is your IR and that is your IY and IB. Only your IR is sustaining, and it's supplying. It means in that phase only 10 ampere current is passing, and just the circuit has been open, so it's a 0 ampere has been shown. Okay, it's 0 0, and this is your 10. Okay, so we'll see that with the same formula what we have used earlier in the earlier question, that is your IR0, IR1, IR2, that is your matrix of 0 and 2 equals to 1 by 3 matrix of A, your Frater, and your current, that is your RYB, right? This is what VLF. We'll see how we data are given is like RY and YB is given, and you have phase, that is your 10 0 0, and again multiplying. Okay, in this particular segment, if we calculate this into this, so we'll have 10 plus 0 0 equals 10 by 3, that is IR0, and 0 sequence 0 sequence component is present, and then is your IR1, that will be this into this. So again it will be 10 plus 0 0, that is your 10 by 3 ampere. Then there would be your negative sequence component, that is IR2, this multiplied by this, so it will be 10 plus 0 and 0, right? So it consists of all three. Okay, all three are written. Okay, so this also satisfy if you have a three phase balanced. Okay, if a balanced three-phase system, the current in each phase is 10 ampere, and the phase sequence is RYB. Now the sorry, not this. This is a question. Okay, it says in a three-phase system, is unbalanced. All the three sequence components are equal. Okay, so we have seen two things. One is for the balance. In balance condition, only positive sequence is present, and in a three phase, if it is unbalanced, all three sequences will be present. Okay, now we'll go move ahead with the another segment. Okay, the observation 3 that we see, okay? That is your for the flow of positive and negative sequence current, the return path through ground is not necessary. Okay, you have to be very peculiar. The return path through ground is not compulsory. Okay, it's not mandatory. Only the negative or the return path would be your ground. Either it may be chosen in any other format as well. Either body could be grounded and it could be not grounded. Okay, neutral path would be not there. Okay, yeah, we'll see how it is being done. So, okay, how they have mentioned the condition of neutral, that is your ungrounded, solidity grounded, or reactance grounded, has got no effect for the flow of positive sequence and negative sequence component. Again, this is what it has to be say in this portion. Either you follow this terminology or they follow this terminology. Okay? For the flow of positive sequence and negative sequence current, return path. Okay, this is a return path to the ground is not compulsory, or the conduct condition of neutral, ungrounded, okay, or the solidity grounded or the reactance grounded has no effect for the flow of the current of the sequence. We'll see. You can see from this equation, okay, as we know, since, okay, this is since IR1 I1 plus IB equals to 0, and also IR2 IY to IB2 equals to 0, if we connect two particular part that let's consider this is a source and this is as a load. If you're connecting, so this IR1 would equals to 10 ampere, that is your IR2. Okay, and if it is connected in these two part model, the IR1 equals to minus 3 ampere, that is your I/2. Okay, and IB1 equals to minus 7 ampere and I1 equals to 6. Okay, now this is the if incoming current is equals to 0, then outgoing current would be a 3 uh, this 3R0. Okay, now over here neutral point is ungrounded. This neutral point is ungrounded. And if we see, okay, if we go ahead with that particular point that your neutral is ungrounded, okay, then incoming current would be a 0 if neutral is ungrounded. Okay, a negative sequence means flowing in the opposite direction. Okay, this particular part, that is your IY1, I1, IB1, okay, these segments are flowing in the opposite direction. Okay, now see, so from if it is been grounded, okay, if it is being grounded, okay, this I and 1 would be your IR1, IY2 and IB1. Okay, that sum up will be for these three. Okay, now that will be equals to 0. Okay, all the current would be flowing. Now what happens if there is a effect? If see, if this is your xn, okay, that is also been grounded. Okay, if your xn if has any effect on this flow of current, then this in would be equals to 0, and there will be also voltage drop. Some of the voltage drop will be there definitely. Okay. So that's why it says there is no effect either it is been grounded or not grounded. The flow of your the main learning point is over in this segment is the flow of positive and negative sequence do not depends on the that particular point. Okay. Now, no return path means any or two path out of three phase will act as a return path. Okay. It happens if there is no return path means one or two path out of three phase fire act as a return path. Okay. This is what is the observation we see. Now next observation, for the flow of zero sequence current, return path through the okay, for the flow of zero sequence current, the return path through the ground is compulsory. Okay, it is not compulsory for your negative and positive, but for zero it is compulsory. So whenever you could also say whenever any ground, if ground fault is there, the presence of zero sequence current is obviously be there. Okay, now this means let's see, or the conditions is also say the condition of neutral has got effect for flow of zeros of current. Okay, now if we take all the zero sequence current as IR0, IY0 and IB0, that will be equals to 3 IR0. Okay, now if Xn is used to limit the earth fault, no phase fault, okay, as the fault occur, it goes through the ground by using this. Okay, by using this. Okay, so this is your thing what is being observed or we could see out of this. Okay. If not grounded, incoming current to the supply is 0. First of all, okay, incoming current to supply is 0, and the current leaving to the load is your 3R0. Okay, incoming current is your 0 and leaving current is your 3R0. Now, so what happens, there is this KCL is not satisfied in this condition. Okay, therefore no current would be flowing. Okay, so that's why that is right. Okay? The neutral ground reactance has to be considered in geosperm. The same thing what we are studying. Okay, grounding having 0 and act as a perfect conductor. Okay, now observation 5, what we have to see about this right now. Okay, the original a three-phase system, that is your RYB, is mutually jointed network, whereas the sequence network, that is your positive, negative, zero, are mutually disjointed networks. Okay, this we have seen in previous class also in another manner, but this is the observation you have to keep in mind. But what we had in the previous class in the same way, the three the original three-phase system RYB is a mutually jointed, okay, and the negative, whereas the sequence negative and so sequence network, that is a positive, negative, zero, are mutually jointed networks. Let's see. Consider this transmission line. Okay, we are considering only one transmission line, that is your RYB, which has XS, and this is a mutual. Okay, the self reactance and is a mutual reactance between these two. Okay, if we form this particular form in the form of your specular, that is your V into V equals to XR. Okay, this X is a reactance matrix. Okay, RYB, 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 and it is being solved in this manner. It will be like this particular segment. This will be RYB, this will be your XS, and these two segments will spill with your mutual reactance, this is RYB. Okay, now if the off diagonal elements is equals to 0, okay, if the off diagonal elements, this is the off diagonal elements, okay, if is equals to 0, then they are mutually coupled, okay, in condensed form. Okay, if the off diagonal is not equal to 0, okay, if not equal to 0, then it is mutually coupled. Okay, if these values are not 0, then it is mutually connected. It's obvious the part. No, this is the obvious thing. Now, if we convert, if you want to know what will be the sequence reactance part, we could consider in this form. We have taken this V into X into I, V equals to X matrix into I, okay, where V could be written your A operator into phase, right? We know this, your V R Y B equals to 1 by 3 A of 0, 1, 2, right? This manner, we know this, we could replace in this particular format. Okay, we could replace this, we could replace easily, we could replace. So we have replaced that particular segment in the equation. Okay, we have replaced that particular segment in the equation. Okay, this, and XS is kept as XS, and I also is converted into your phase sequence components. Now if we take this into the opposite direction, so V0012, that is your voltage of phase voltage, okay, phase component voltages, okay, would equals to A inverse of X into A into A0. Now this is your sequence impedance, okay, that we have seen yesterday. That will be your X012 would be equals to A inverse X into A. These are the A operator, that is your 111 111 A square A square, okay, inverse of that. This is your that particular format. In this way, it has been converted. Yesterday, we and last previous, not yesterday, we'll say in previous class, we'll see now. So, what will be the value of this on solving? On solving this X012 would be equals to X plus 2xm. Okay, Xx equals to 2xm. Your this is your xm, and this is the xm minus x, and all the non-diagonal part is your 0 now. So from this, what we get is your x0 is your x plus 2xn. 2xn, I will write a little bit little small so it could adjust. Okay, it states that your x0 is equals to xs plus 2xn, whereas your positive and negative sequence components, that is your x1 and x1 is equals to x2 equals to your xn minus xn. Okay, these two we derive from this particular matrices. Okay, see over here it is singular. Okay, zero sequence component, and these are negative and positive sequence component. Okay? Now, in this, what we have to note and what we have to see is in the sequence impedance matrix shown above, the off diagonal elements are zero, right? This means the three sequence network are mutually disjointed. Okay, when it is being told, as earlier it is being stated, that xn value will be the if non-diagonal elements are non-zero, then it is mutually jointed. But in this category, we have observed that in sequence impedance matrix, okay, the off diagonal elements are zero. Okay, this means the three sequence network are mutually disjointed. Okay, now the values of sequence impedance are now x1 and x2 is equal to xs minus x, right? It is being written positive and negative sequence components, okay, of the impedance are your xs minus xn, and your zero sequence components is your xs plus 2xn. Okay, so this we what get. So we have seen five of the derivations and all. Not derivation, we'll consider that as observation. The very important observation that should one should keep in mind while going through a lot of things in this. Okay. Okay, we'll see this problem. In this, what it is given is they have provided this data, that is your EAB, EBC, and ELC, right? They have given us this data. Now, and we have also your the resistance value over here. You could see that is IAJ 2, and between IB is your J3 and EC is your J4. Okay, means it is a value. This is the value of that. Okay, what do you have to find? You have to find your current phase components. Okay, we'll see. As we know, I equals to V by R or V by Z. So using that formula, we are able to find your IB, IA, and your IC value, where A value, B value, C value, voltages values are being given very clearly. Okay, then this will be your EA by J2. Okay, for J, we could always write your 90-degree segment. Whenever you have to remove J, we have to convert that into your polar form, you will convert as a 90-degree in this case. Okay, so I'm substituting this value at this particular position, that is your 10 A is to zeros, and this will be your J would be your acting as 90 degree, and when it goes up it becomes minus 90 degree, and 2 by it is 5, so it is your 5 angle of 90 degree, that is your IA. Now, IB is given EB by 0 3, J3, and this is your 90 degrees, almost a 90 degree. When it will go, it will be a 10 by 3 minus 90 by 90 degree, right? So this will be a 3.3 and 180 degree, okay, minus 180 degree, okay. And in IC part, and IC it's a J4 means 490 degree and it's a 10 120 degree. Till go, it will be working as a 90 degree. So it will be your 2.5. That's your 2.5 into 30 degree, as 120 minus 90 is your 30 degree. Okay. So now we know all these data. Now we could replace that in this. So for finding IA1, okay, so finding your IA1, it will be 1 by 3 IA plus A IB plus A square IC, right? From that matrix, on substituting this value, we'll get 3 minus 180 degree, right? This is what we have to find. That is a positive sequence. And this particular question, it was asked to calculate positive sequence component, means it has been given this and it is given your ZA, or we write in XA, J2, J3 and J4, and they have asked find positive sequence component of current. Okay, they have asked this data has been given and they have asked to find only uh, positive sequence component of current. Okay, so that's why we have solved only for IA1 value. Okay, yeah, we have seen. We'll see rest in your rest of the segments. Okay, rest question will solve in rest of the segments. Okay, we'll see a lot of numericals in it, or we could find out a lot of segment in this. Okay, so we'll meet in next class for more detailing part. We'll see a lot of segment, and we'll also observe a lot of uh, points that is being left. Okay, we'll proceed with this. Then there is your sequence impedance. Okay, we'll see these questions and all, and we'll proceed with another segment. You could see this particular format as well. Okay, this is what I have already seen. Okay, in the observation it is being given. Okay, and then this particularly this phase only the load is applied, okay, with your neutral, and these are the zero. So if you have to find your negative mm, uh, sorry, that you have to find your this phase sequence component of current for this particular segment. So you could directly write your IR0 I1 equals to 1 by 3 this A operator matrix into all three components where these uh, IY and IV is 0. Okay, this data has been given as 0 based on this figure. So only you have to find with this. So what will be the answer? So this we know it will coming as a, as the current value is your IR only, there is no numeric data is given. We could sense that your IR0 would equals to IR1 would equals to, okay, this value, where if you multiply with these into this, only this factor would be getting your output, right? So we'll get your one data, that is your IR by 3. Okay, this data see over here, IR by 3. Only this your data you will get. Okay. So if there is any doubt, you may ask or you may message, please. If not, I will be dealing in next class with lot of the sequence. So you all should speak. Okay, you should also ask. Either you are not understanding or you are not practicing. I don't know what you are doing, but you should ask some of the things. It's not necessary that I am only will be asking you and you will be then only you will be sharing any doubt or you will be responding us. Okay, if you ask, if I'm going very early, if I'm going very slow, you may also comment or prompt us. Okay, that's the way we could deal with it, or we could understand, or we could uh, be more frequent on this understanding purpose of these things. Okay, nevertheless, it's okay, it's fine. If you are practicing your answer when we solve, okay, when we answer, you generally respond, but it's like whenever I am asking, then only you are responding in this. Okay, so that is the only concern to me, that sorry, you should read and you should answer. Okay, you should prompt that, this will be this and this will be this. Okay, that is the active classes. Okay, fine. Mm, so okay, we'll see ya, we'll see you in next class. Fine, we'll move ahead with another category and another segment. If we try and if we do these segments, okay, this will be helpful for us only. Okay, so yeah, thanks for joining. We'll see you in next class. Yeah. Okay, okay.